All right, so these are the notes for the quadratic formula. So the first part is just going to be talking about the discriminant, which is a part of the quadratic formula. So what we have here is, says, in the quadratic formula, the expression b squared minus 4ac is called the discriminant. Of the associated equation, ax squared plus bx plus c is equal to 0. So your quadratic function in standard form set equal to 0. So in the quadratic formula, notice that b squared minus 4ac is located underneath the radical sign, right? So the discriminant is b squared minus 4ac, not the radical part of it, okay? Now, when you work out the discriminant, you're going to get three types of answers. So the value can be either positive, and if that value is positive, so when you work out this formula and you get a positive value, then you're going to have two real solutions. And what that pretty much means graphically is that your quadratic function is crossing the x-axis at 2 points, giving us two x-intercepts. So if your discriminant is positive, you have two real solutions, and it crosses twice on the x-axis. Second type of answer you can get is the number 0. So if you work it out and you get the actual number 0, then you're going to have one real solution. This shows one x-intercept, so it just touches the x-intercept at that one point, so you have one real solution. And then last, your answer in the discriminant, the value can be negative. And if it is negative, then you have two imaginary solutions. So two imaginary means it doesn't actually cross the x-axis, there are no x-intercepts, but we know from complex numbers that we have an imaginary solution, and I will be a part of our answer when it's algebra, when we're doing algebraically. All right, so these next few questions here, it says find the discriminant of the quadratic equation and describe the number and type of solution. So again, we're using that formula b squared minus 4ac. Okay, so for this one, let's first identify what a, b, and c are. So make sure it's in standard form set equal to 0. A is in front of x squared, so a is 1. B is in front of x, which is negative 8. And c is the c, which is, or the constant, which is 10. So we do b squared, and make sure you do put this in parentheses, minus 4 times a times c. And this one, I'm just going to type it into my calculator so I don't make an error. So type it the way you see it. And we get 24. So we see that 24 is a positive number, so we're going to have two real solutions. So once again, find the discriminant, 24, and describe the number, 2, and type of solutions real. So there are 24, and it's two real solutions. All right, for the next one, we're going to do the same thing. We're going to make sure it's in standard form, set equal to 0. We're going to identify a, b, and c. So a is in front of x squared, which is 1. The b is in front of x, which is negative 6. And c is 9. Let me plug it into the discriminant formula. All right, then we type it into our calculator. Let's kind of lower the... There we go. And we get negative 42. Did forget one thing here, so let's go fix that. It was supposed to be negative 6 in parentheses squared. And it is actually 0. There's our value. So our discriminant is 0. And we said if we got 0, we get one real solution. All right, and then for the last one here, again, it's already in standard form, set equal to 0, so we're going to identify a, b, and c. So negative 6 squared minus 4 times a times c. we get the value of positive 4. Which again would be 2 real solutions. All right, so that's how you do the discriminant. All right, now the next thing we're going to do is we're going to use the discriminant along with the quadratic formula to solve all quadratic functions, or whichever ones they give us to do. So let a, b, and c be real numbers such that a cannot equal 0. The solution of the quadratic equation is x equals the opposite of b plus or minus the square root of b squared minus 4ac, all of it divided by 2a. All right, so right here, it says x squared plus 3x equals 5. Solve this using the quadratic formula. Well, first off, it has to equal 0. So we're going to move the 5 over by subtraction. Now we're going to identify our a, b, and c. So a, b, c. A is 1, b is 3, c is negative 5. Now I like to work out the discriminant separately. So that's going to be your b squared minus 4ac. So b squared minus 4 times a times c. Put this in the calculator real quick. And we get 29. Now this just tells me I'm going to have 2 real solutions. Now this is going to be my b squared minus 4ac. So let me write the quadratic formula here. So this is something you do need to know. All right. So when we work this out, x equals the opposite of b. So the opposite of b is negative 3. Plus or minus the square root of the discriminant, which we figured out to be 29, over 2 times a, so 2 times 1. 29 is a prime number, so we have x equals negative 3 plus or minus the square root of 29 over 2 times 1, which is 2. And this is my final answer, simplified. All right, let's take a look at example 3. So this one says, again, solve it using the quadratic formula. So first we're going to bring the 12x over by subtracting it. And we're also going to add the 4 over so that the function is equal to 0. So we get 25x squared. Negative 8x minus 12x is negative 20x. And then we have a plus 4. All right, we're going to identify a, b, and c. So a, as you can see right there, is 25. B is negative 20. And c is positive 4. Okay, so we do the discriminant. So b squared minus 4 times a times c. So 400 minus, looks to be 400, which is going to be 0. So that means I should have 1 real solution. So x equals, so we're just following the quadratic formula, x equals opposite of b plus or minus the discriminant. So the opposite of b in this case, the opposite of negative 20 is positive 20, plus or minus the square root of 0 over 2 times a, which is 25. So 20 plus or minus the square root of 0, because the square root of 0 is 0, is just 20. And 2 times 25 is 50. And 20 divided by 50 is 2/5, which is our 1 real solution. All right, down to the last question here. Again, it doesn't equal 0. Let's go ahead and bring the 13 over by subtracting it. So we have negative x squared plus 4x minus 13 is equal to 0. So we're going to identify a, b, and c. A is negative 1, b is positive 4, and c is negative 13. So we have b squared minus 4 times a times c. All right, so let's see if we can do this one. And we get negative 36. So negative 36 tells me I'll have 2 imaginary numbers, but when I'm working out algebraically, I should have an I in my solution because it is imaginary. So x equals the opposite of b, which is negative 4, plus or minus the square root of the discriminant, divided by 2 times negative 1 is a. So negative 4. Now, if you recall this right here, we usually make it positive, and then we bring the I in front. That's our imaginary. And the square root of 36 is actually 6. So it's going to be plus or minus 6i over 2 times negative 1, which is negative 2. Now, when we look at this here, we can see that these three terms are all divisible by 2. But we want the bottom number to be positive if possible, so we're going to divide everything by negative 2. So negative 2 goes into negative 4 twice. Negative 2 goes into 6i 3 times. So it's going to be plus or minus 3i. And negative 2 goes into negative 2 once, so we don't really need to put divided by 1 unless you want to. There you go. 2 imaginary solutions. 2 plus 3i, 2 minus 3i. All right, down to the last question here. And this one says, modeling a launched object. So a juggler tosses a ball into the air. The ball leaves the juggler's hand 4 feet above the ground and has an initial vertical velocity of 30 feet per second. The juggler catches the ball when it falls back to a height of 3 feet. How long is the ball in the air? Okay, so for this one, we're just going to take the equation. So one of the equations we had was h equals negative 16t squared plus v sub 0 t plus h sub 0. Now, v sub 0, this is going to be your initial vertical velocity. So that's going to be 30 feet per second, so 30 seconds. H sub 0 is going to be your original height. So in this case, 4 feet was where it started. That's our original height. And then last, our final height is when he caught it at 3 feet. Okay, so we're going to substitute those numbers in. So h is going to be 3 feet, negative 16t squared, plus the initial vertical velocity was 30 feet per second, plus the initial height was 4 feet. Now, excuse me, this wasn't ready to solve yet, so we're going to first do is subtract the 3 over to the other side. And 4 minus 3 is positive 1. All right, from here, we're going to solve this using the quadratic formula. So we are at series standard form set equal to 0. So a is negative 16, b is 30, and c is 1. So b squared minus 4ac. So let's put this in the calculator. And we get 964. All right, so now x equals the opposite of b, so negative 30, plus or minus the square root of the discriminant, which is 964 over 2 times negative 16, which is going to give me negative 30 plus or minus the square root of 964 over negative 32. Now, this is a real life application problem. So the juggler catches the ball. When does it fall back? Here it is. How long is the ball in the air? So we're talking about how long, which is time, and time needs to be positive. So we're going to work out two solutions. The first one is negative 30 plus the square root of 964 over negative 32. And the second one is negative 30 minus the square root of 964 over negative 32. And we're going to see which one gives us the answer we're looking for. Okay, so I like to do control divide here to make it a fraction. So negative 30, we'll do the plus one first. Square root of 964, arrow down, negative 32. So that's a negative. And we're going to round it to 3 decimal places. So 0.03, and then we have 7. The 7 rounds the 2 up to a 3. Now, the problem with this answer already is the fact that it's negative 0.033 seconds. You can't have negative time, so that's going to be wrong. Let's check the other one. So here I just arrow up twice, and I highlight it, hit enter, and I go to that plus sign, and I change it to a minus. And 1.9077 becomes 1.908 seconds, and that is the positive answer I'm looking for there. Okay. Now, this last part of the notes right here is just talking about the methods we've used for solving quadratic functions. when they're appropriate to use. So like graphing is an approximation of solutions. Using square roots is when you have u squared equals d that you can solve. Factoring, if you can factor it. Completing the square and quadratic formula can be used to solve any quadratic form or any quadratic function. But completing the square I prefer to use it when my a value is 1 and my b value is even. Other than that, I just go straight to the quadratic formula. All right, and that completes the notes for using the quadratic formula.